Okay, thanks for tuning in to this audio abstract with Sophia Nymphius discussing validity of change direction and agility assessment. So welcome to the audio abstract and thanks for tuning in, Sophia.
Thanks a lot, Rob, and thanks for the opportunity to chat about this paper. Just thanking my other co-authors on this, Sam Callaghan, Neil Bezotis, and Rob Lockey, all contributing heaps to the length of this paper. This is just more like a brief review in Strength Conditioning Journal, and what had happened from prior research studies is we had realized that probably the way we're assessing both change of direction and agility currently, or the measure that we use to define performance, may not be the best. We're not saying that what we have we should just throw out the window, but we're realizing that we can definitely do things better. So we thought before we continue doing more and more research, just using the same old measures of total time and some kind of obstacle course or something for various change of direction tests, we should just take a step back and look at what we're already doing. So we've done a bit of a brief review, but the format of our review is really more about asking ourselves better questions and making sure we have good answers to those questions. So really just being critical of ourselves, and then hopefully igniting some excitement in the research that can give us practitioners and researchers just better findings that really take us to the next level. So with the start of this paper, we probably should start with definitions and delimitations so that everybody's on the same page. The primary definition we just need to take care of is validity. So it might sound self-evident, but we're hoping that every test we do measures what it purports to measure. And that's what we're saying we might not be doing really, really well. Then reliability is a repeatability, which we feel that most tests do very well. And then within validity, you can actually split it up into different types of validity as far as the research goes. So you've got construct validity and discriminant validity, which are the two that we just wanted the readers to make sure they have a hold of, because they're really important to understand well, to understand our critical evaluation of our own research or the research that's out there. So construct validity means that basically, if we put it in terms of change direction and agility, that the test really represents change direction and agility that we're trying to measure. So that seems like it should be self-evident, but depending on the measure we have, it may not be. And then discriminant validity, which is the most common way that people say a test is quote-unquote valid. And it's put like this. If we take 3 groups of athletes, one is novice, one is intermediate, and one's elite, that if a test is valid, the athlete groups will test differently. So the elite will be the best, followed by the intermediate, and the novice the worst. So that's basically the 2 underpinning types of validity that you may choose to evaluate in research. So just so another factor that we need to think about is that is the word change of direction, or the abbreviation here COD. In this research paper, or in this brief review, we're talking about actually changing direction. So the physical ability to change your direction, and that's independent of whether it's in pre-planned, so typical change of direction, or an agility test, so in response to a stimulus. So if you have an agility test, there's always a physical capacity to change direction in it. That's what we're talking about, is our measure really measuring that aspect, and separately you have perceptual cognitive ability. But that doesn't matter as much for us as far as questioning whether the measure of changing direction is being properly evaluated. All right, all that out the way. Now we go into some of the questions we had. And hopefully as you go through the paper, you start to get some clarity and or some suspicion about what we're doing. And I think that what we've done in this paper is to admit we don't have all the answers, and to admit that I think we can do a lot better. And I really want to know the answers to these questions, so I was willing to critique and even maybe critique myself, so that the next papers and the new, say the next 10 years of research on this really pushes our understanding. So the first one was, how does linear sprint speed influence change of direction performance measures? I won't spend a lot of time on this because we actually published a paper just last year, so 2016, which we have an audio abstract on, that kind of alludes to the fact that, in a majority of our change of direction tests, there's so much linear sprinting in it innately that you can't help but your linear sprint speed innately confound the results of your quote-unquote change of direction test and or agility test. So let's take, for instance, in a prior audio abstract, the 505, you change direction, but the change of direction that happens in about 0.6 of a second. Yet the test is on average 2.5 seconds long. So that means that a majority of the test, what you're actually doing during a test that is supposed to be measuring change of direction ability, is actually measuring your sprint capacity. And so if you think about the definition of validity that we just went through before, and that it's actually measuring what it purports to measure, yes, it does, but it also measures some other things that it doesn't purport to measure. And because of that, you'll see large correlations between most linear sprint tests and a majority of change of direction tests. And that could be a 505, that could be a T test, that could be an Illinois, and that's because innately there's so much linear sprinting. So I guess the answer to that question is yes, linear sprint speed vastly influences our current measures of change of direction performance because most change of direction performances are measured by total time in seconds. The next question that we had is how does angle and entry velocity influence change of direction performance? And the reason that we ask that is because there are a huge number of change of direction and agility tests, and they have all types of run-up speeds and all types of cuts. And, there's quite a few papers that have looked at correlations between multiple change of direction tests and have concluded that they're all pretty much the same because they highly correlate. But a high correlation is considered anything above 0.7. Now, 0.7 squared is just about 50%, so they explain each other by 50%. In my eyes, that's not a lot of overlap. It's quite a bit of overlap, but you wouldn't take one in place of another if it only explains 50% of your ability in another test. So what we realize is that all of the different tests, they do actually measure different types of capacities, mostly because as you increase entry velocity, the physical demands of the test start to increase. It's a lot easier to stop and go if you're only moving at 2 meters per second than 5 meters per second. That's innate. And so that's controlled by the run-up velocity. So we've realized that, you have to start with why you're doing a test. What do you really want to know? What's really critically important before you select that test? And realizing that the entry velocity, if it's not measured, is an assumption of that test. So then we started to question, is entry and exit velocity really what we're trying to look at? And I think this is where we're starting to think about more valid assessments. Instead of total time, we want to know how fast do you get in and how fast do you get out in those intimate couple steps in between the actual change of direction. So think the cut and the go. So how do you get in? How do you get out? Because that is that quote unquote highlight reel step that we're really looking to assess. So we're realizing, okay, total time, that's pretty confounded because linear sprint speed's there. And the angle and the speed of entry based on the type of test, that really can change someone's performance and their quote unquote physical capacity. And so I think those are some of the things we need to understand when we read the research and conclude about the research, and understand as practitioners when we choose a particular test. The next question we kind of went about, going further from a practitioner brain, is should body mass be considered in change of direction tests for contact sports? This came from the sprint momentum calculation. So Dan Baker did this early with rugby league players, and conceptually it makes a whole heck of a lot of sense. Listen, as athletes develop, if they can maintain speed but gain body mass, they gain momentum. And if this is a contact sport, you're winning. So, if you're doing physical performance tests and your athlete doesn't improve in speed, but they also don't decline in speed, in our world, that's actually beneficial if they've also simultaneously increased body mass. Same thing goes for cutting as well. If athletes can cut, so change direction rapidly, and they can do so at a higher body mass, especially in contact sports, think about this. Oftentimes when you change direction, it is for evasion or it's to contact someone for a tackle, right? An immediate cut. So if you can do that with the same capacity as a counterpart, so same velocity in, same velocity out, but you weigh more, you will be harder to tackle or a better tackler because you have more momentum against that individual. So we should consider that, because at the end of the day, we need to make sure that the change of direction manifests itself well into performance. And body mass is a critical factor, particularly in contact sports. And we haven't done that well. And we're just starting to do it well, really, in even sprinting for contact sports. So we just thought maybe we should bring this up and bring it to the attention. Because remember that this whole entire review is really about, hey, we've done these things, but I reckon these things can be done better when it comes to assessing change of direction. So those 3 questions so far could already make a big difference in us as practitioners, how we look at change of direction, or researchers and how they evaluate it. Hey, maybe we should look at entry and exit velocities, how fast we allow those people to come in, the demand of the cut. Are we including the whole time in our measure, which maybe we shouldn't be, looking at something more specific like velocity? And then this last one, should we also include mass in the metric and make it momentum? And then this other question, which is, it's really a practitioner-based question, but is there more than just quantity to change direction performance? And this comes from that very first question. We love a quantity. We love a data metric. We love, it took them 2 seconds and it took this other 2.5. 2 is better than 2.5, you win. But what happens when you get similar performances, but the similar performances aren't a similar performance? So 2 athletes, one has the good style, they're fluid, their mechanics are clear. The other one, it's ugly, but it gets the job done. Now, at the end of the day, you just got to get the job done. But as we know, when you have to repeat that day in and day out, we know that that's going to influence their susceptibility to injury, the longevity that they can hold their performance because they've got a lot of force leakage or wasted movement. So we've also said that in conjunction with the quantitative metric, we definitely should be looking at qualitative metrics because it tells you something. And we know that athletes that are athletes do what athletes do well, and that's they cheat. So just as an example, we actually just gave an example here of an athlete that had pretty better than average left and right performance. So better than average, you're not going to say, hey, you're crushing the team for performance on the left and the right side, so we're going to work more on change of direction. In this instance, it's just that you have one really, really preferred side and one exceptionally preferred side. So you're just great on both sides. But when we look at the performance of this athlete qualitatively, we start to realize that those number differences, although they're small, you're still better than average on both sides, but the qualitative performance tells us that your left and right performance are both a function of a really exceptional side doing the work on both sides. So that'll make more sense as we look in here. What basically happens is that the athlete uses this left limb really well, and they drive out, and that's for a left cut, as you would expect. Then we look at the right side, which doesn't have as good a performance, but again, they're above the line. They're better than average. So, you're cutting hairs here to say this athlete needs to work on it. But they actually get that better than average performance by using a qualitatively different technique of using the left leg again. So you make the assumption, if you don't use a qualitative assumption, that when you test the left and right side, that you're testing the left and the right side. And if we just look at the numbers, all we have are the numbers and a big assumption that we've tested the left and right side. Really what we've done on this athlete is we've tested the left side twice. And we know that by looking at how they come into this cut, and what they do is they heavy load on the inside leg here, where on the left side cut, they heavy loaded on both or the outside leg. So they did an inside cut turn on one side and an outside cut turn on the other side, which basically amounts to using the left leg twice. which means they've maybe got a little bit of an avoidance strategy on the right side, which they actually had a prior injury to 2 years ago. And that's 2 years out. But as we know, if we don't watch those athletes closely, they find a great way to cheat. Now, from a practitioner standpoint, if we don't take that qualitative assessment in combination with our quantitative, what we're saying is that we might write a program and say, hey, this athlete's great on both sides, and not make that athlete work on that avoidance strategy. So when they do have to use that right side in performance, they don't have the time to use their modified strategy. That's when they run into problems. So that was another question that we had. And I know that in the research we can't look at both all the time, but this paper was intended for both researchers and for practitioners to take a step back and go, how are we evaluating change of direction and agility performance, and is it good enough? And then I think the last part is giving us hope. The last part is that the question was, what are some recent changes in assessment of change of direction performance we've seen? And we are taking definite bounds forward. I'm not writing this, we didn't write this whole review to say we're just awful and everything we know is horrible. But some of the more recent evaluations is to take a focus on what center of mass performance is doing. Because you can't go anywhere without your belly button, and that's basically what evaluating center of mass. So when we say someone changes well, we're basically saying that center of mass goes in somewhere, decelerates, and then reaccelerates elsewhere, or it changes the mode of travel. It goes from a sprint to a shuffle, or it goes from a sprint to a back pedal, or a sprint to some other mode of travel. All of those are really good changes of direction, but we want to see what's happening to the change of direction at the center of mass. So that leads up to some of our colleagues' work, so Hatter and his colleagues, that's Martin Boucher's group, I believe, and they used a laser distance meter or a radar gun just on the center of mass, so targeting at the hip or at the back, and looking at how the center of mass goes in and out of cuts. And interesting with that, they propose that maintaining velocity is the purpose of change of direction. And that's a different story to others that look at what we call a lateral displacement or lateral velocity as an evasion measure of change of direction. So with our performance tests, question number 1, linear speed, we basically are saying that you want to get from point A to point B as fast as possible, and that is good change of direction performance. But as a practitioner, we know that sometimes evading doesn't get you from point A to point B as fast as possible, but it does get rid of your opponent so you can successfully get to point B. And so that goes back to why are you testing, or what is it you're trying to measure with change of direction? Sometimes it is point A to point B, and that, I would say, is the ability to maintain velocity despite a change of direction. That's one type of change of direction. The other one is trying to get from point A to point B with effective horizontal velocity, which is evasion, and that's a different type of measure. And we can only look at those things, those two metrics, or those two measures of performance, if we're looking at how the center of mass is moving, not just the time between A and B. So we are definitely moving into that. In the research space, they look at it using Vicon or 3D motion assessment. That's fine. It's still the same conceptually thing, but that's where we're going. And as technology it moves faster than we can keep up, I'm certain that measuring our center of mass will be an affordable option for coaches in the future. So we have to start thinking about it now, even though I know it's not currently maybe something we can do today. Some of us may be able to use a laser distance meter or a radar gun, but those of us that are still using timing gates or the stopwatch, then we can maybe go back and take those things we've just chatted about, a qualitative assessment, and you can use free software to look at the center of mass change as long as you've done your proper biomechanics and you've calibrated the screen. But there's definitely ways for us to look at it, at least qualitatively, how well the center of mass moves, in concert with what the question is. So why are we doing the test, and what are we trying to get out of it as far as assessing change of direction? So we start asking better questions about change of direction, not just, is your change of direction good or bad? Well, it depends. Really does depend. It depends, good or bad depends on what you're trying to do. Are you trying to evade, or are you trying to maintain velocity? Both of those are required in sport, so they might be measured differently. So I guess, the same concepts that we've just talked about for change of direction, it doesn't matter, like I said, if it's in response to a stimulus or not. I think we can start to look at our agility measures, and then instead of just looking at perceptual cognitive time and total time as our physical, we can start to look at the entry velocity, exit velocity as the actual physical performance and the perceptual cognitive measures there for agility. The other thing that we noticed when we were critically evaluating agility is a majority of the agility tests stick to 45 degrees. Whereas one of the things the pre-planned tests have done a good job at is looking at doing the around-the-clock measure. So now we have tests that at least evaluate, like a 135 cut, a 90, a 45. The 135 is a cutback, a 45 cut, and a 90, and then heaps of variations in between. Whereas we have stayed pretty confined to the 45-degree cut. Only a couple of individuals have evaluated some broader cut ranges. So we can definitely look at that differently, because if we go back to that question, does entry velocity and angle matter for what the performance is? It does. We know it does. And therefore, with that said, we need to start expanding, because we've done quite a bit of research now in the 45 cut. So as individuals are more interested in agility performance, and is it more the physical? Is it more perceptual cognitive? Is it a mixture of both? I mean, you could think about going somewhere fast as heck, but if you can't physically go there, I guess it doesn't matter. So, of course, it's a combination. But I think in order to understand the full suite of the importance of the perceptual cognitive on the physical capacity, we got to broaden it out as we have in change of direction tests. So get away from that quote-unquote Y-shaped agility. So, I guess that answered the question. The next question in itself, we asked, is there a use for both change of direction tests and agility tests to develop athletes? And we definitely think that. It's a little bit like understanding the sweep. We made an analogy here that, pre-planned tests are like a counter movement jump, and agility tests are like a drop jump. The drop jump, you have the unexpected, the neuromuscular system has to know when it's going to pre-activate for a good performance. Same thing, someone with better perceptual and cognitive ability has a longer time for pre-activity prior to the cut, and subsequently has a better performance. So, there's times when you need to know just the physical capacity, and then there's times that you need it in concert. So understanding the development profile of the athlete, we absolutely need both. And on top of that, I think once we start doing a better job of looking at a real measure of change of direction ability, so entry velocity, exit velocity, in combination with the body mass at different angles, that then we'll be able to say whether we need both tests. I don't think we've done a good enough job really measuring change of direction ability, the physical capacity yet, to just rule it out and just rely totally on the agility thus far. So I think we actually have a lot to go. So I guess what we ended up doing is giving some recommendations to the research and the practitioners at the end that I probably just want to go through before we wrap it up, because it is quite a long article, but it's an article that I hope starts spinning other people's minds, and some things you're going to like and some things you're not going to like, but that's exactly what we need in order to push forward. By no means do us, the authors, think that we had all the answers. We actually probably ended up with more questions. But these are our practical applications. So I'd like to wrap it up, because that's where we like to stick. Is, one, I mentioned it a couple times, consider the why of the testing. So are you trying to evaluate one's ability to maintain velocity? We'll call that maneuverability. Or are you trying to evaluate one's ability to evade or to rapidly close space? And that's really the cut version, so an actual change of direction. And how the test is set up will determine which one you're measuring, and what your actual measure is. Total time basically just wants you to get from point A to B fast, whereas entry and exit velocity might give you more descriptive measures of how one handles the entry and exit velocity and how much they evade someone. Two, this came from some work by Sayers, and he did a great little study with looking at the center of mass using Vicon, that maybe we should shorten the distance over which change of direction is measured. So instead of doing long change of direction tests, looking at things that are over a much shorter distance, and those times will be a lot closer to what I mentioned before. They'll be closer to times that we get when you look at change of direction deficit instead. considering in a practical world using that change of direction deficit, if you already have the linear sprint time and the total time of your test. And when you don't have timing gates, that's okay. We still use stopwatch, but why not use, all of us have phones that can actually measure at high frame speeds now, and chuck them into some of the free software we have to actually look at the center of mass velocity. And then finally, one of our practical applications for agility, although we didn't talk a lot about it here, is to, of course, use human stimuli, which is a conclusion that came out of the large review on agility, but also for us to consider, broadening the angles at which we use agility tests. That was probably one of the take-homes for this whole review that we had on agility assessment, in addition to, in agility assessment, taking on some of the recommendations we had for any change of direction assessment. So that's, adding mass into the component, looking at the velocities entering and exiting. And one thing I didn't spend a lot of time talking about it, because it's more, maybe at this point, it's more research-based, but looking at not only entry and exit velocity, but entry and exit velocity relative to the time you take to perform that entry and exit velocity, which actually is external mechanical power. So we always talk about external mechanical power in jump tests, and I know there's some discussions on whether it is and isn't relevant, but at the end of the day, the time it takes you to enter and exit that velocity is just as important as the velocity. So if, in order to enter and exit a velocity of a cut, you need to stay planted for a second, you will already have been tackled, per se. But if you can enter and exit that at the same velocity, but the plant phase is only 0.2 of a second, you evade your opponent while also exiting at a high velocity. So considering the time, in addition to the velocity, that is a measure of external mechanical power, and that may be something that's even more beneficial for us for change of direction performance. And we actually got that concept by looking at sprint start performance, and that's Neil Bozotis' work on sprint start performance and looking at external mechanical power of the sprint start, because it's not just the velocity of the center of mass, but it's how long it takes you to get it. Because if you're still sitting on the blocks, that doesn't matter if you come out like a bat out of hell, because someone who took less time on the blocks but at a slightly lower velocity is already ahead of you, conceptually. So we don't know where that's going to go, and we don't know if we can measure that, but all of these things are super exciting for both the practitioner, those practical take home, but really I hope some of the researchers jump in there and grab those ideas and start testing it, because we don't have enough time to do all that research ourselves. So we're looking for some great researchers out there to take it up. So that's pretty much our conclusion. It's a huge review, like I said, that may give you more questions than answers, but definitely leaving it open for us to get a lot better at what we do for evaluating and then subsequently training change of direction and agility.
Perfect. Brilliant. So I know this hasn't been published yet, but where can people get it when it is?
Yeah, it's just going through the final publication process, so it'll be published in Strength Conditioning Journal early in January. Or early in 2017, excuse me. Yeah.
And where can people keep up to date what you've got going on? So ResearchGate and Twitter, best places?
Yeah, so we'll tweet when this is out. Also, we've got a project page on ResearchGate about this. So as much information as we can put up there is already up, and then it'll be posted on ResearchGate and academia.edu.
Perfect. Well, thank you very much again, and we'll speak soon.
Yeah, for sure.
Thanks, Sophia.